So here's chapter 8. And basically, what we're going to be doing in chapter 8, and I'm just going to show you this because well, I can't find there we go. In the sections before this class, before chapter 8 and chapter 7, we actually drew a curve. Well, I'm not going to draw curves. That's just extra work. In chapter 7, we did this, and I'll do chapter 7 in orange. Okay. In chapter 7, we said, what is the probability of x being greater than 40 with a mean of 30 and a standard deviation of 15. Okay, and that's what we did in chapter 7. Okay, so we plotted 40. We said this is 30, and this will be 45, or let's say this will be 45, and this will be 60, and this will be 75, and this would be 30 minus 15 is 15, and 15 minus 15 is 0, and negative 15. Okay, that don't happen, but when you make up something, I made this question up. So, and you plot 40 right here. 40 is about, let's see, 30 to 45. So halfway between would be 37. So 40 would be about right here. And they want to know what's the probability of being greater than a test score or age or whatever of 40. Okay, that's what we did in chapter 7. Everybody with me? Yeah, sure, Hubert. We understand. Yeah, thank you. Y'all suck. All right, blue, chapter 8. They're going to throw something else in there. Okay, they're going to say mean is equal to 30, or they may throw a X bar, or they may throw something different, and they'll say standard deviation is 15. But then they're going to say, what if you pick 10 more people? What is the probability of their score being greater than or equal to 50? Okay, now that's the difference between the two questions that we're going to be starting with, okay? This is chapter 7, and this is chapter 8, and the only thing that's different is that right there. Okay, now they're going to go through a bunch of slides. It's going to take you far, far away from this right here. So I just want to go ahead and show you what we're going to be doing. And that would be, we got to change this into a z-score. And the way we do that is, I'm going to go ahead and write this down so you'll know. The new standard deviation is equal to the regular standard deviation over the square root of n. Okay, and that's what we're going to be using to find the new z-score. Okay, so I'm just going to go ahead and tell you that that's what we're going to be learning right there. Z-score is equal to x minus x bar over the standard deviation. Well, this new standard deviation is going to go in right there. Now that's what I'm going to test you on. So that's a kind of a summary of what we're going to be doing in chapter 8. Okay, so let's go back to the slides. Not important. Let me just go to slideshow, current slide. Samples, future sample mean. Here's an example of a way a question will be set up. We're not going to do it because they're going to show you that they're going to do a lot of stuff behind this question. Said the weights of pennies minted after 1982 are approximately normally distributed with a mean of 2.46 and a standard deviation of 2.02. Now, what does that mean? That means draw the damn curve. Okay, so we already know that from chapter 7. Approximate the sampling distribution of the sample mean by obtaining 200 simple random samples of n is equal to 5 from this population. All right, now what I want you to do is write this question down, and on the second part, approximate the sample distribution of the sample mean by obtaining 200 simple random samples of n is equal to 5. So you're going to go out and ask 5 people. That's one group. You're going to go out and ask 5 more people. That's 2 groups, all the way up to 200. Because a simple random sample means groups. Okay, it's going to be 5 people. And then you're going to do group B, and that's going to be 5 more people. And then group C, 5 more people, all the way up to 200, group 200. Okay, now the computers can do this by making a random sample. You can go in, I don't know if I can do this in StatCrunch. Let me see if I can go through StatCrunch and do it. I don't know. Let's see, where is the homework? Let's see. I don't even know if I've assigned the homework. Where's assignments? We don't have assignments anymore. Homework. They call it assignments in the other classes. 8.1. And I'm going to see if I can just get one with StatCrunch. And if it will work. I don't even know if I can remember how to do it. But anyway, let me see if I can find. Simulate. And we can do Bernoulli. We can do binomial. I'm trying to find just. Well, we can do binomial. And then we can do rows. So that's going to be 200 rows. And 5 people in each row. And the negative will be no. And the positive will be yes. And compute. Okay, I didn't think it's like that. Maybe it wants no and yes. Okay, just forget it then. Oh, I got to put the, okay, binomial parameters, 0.25 and 0.75. I don't know if they want that or not. Well, anyway, wait a minute. What did it say there? Okay. 1 and 1. There we go. And see, this is called a simulation. And if you look, it goes all the way down to what? 200. Okay? And you can go through, well, that's not what I wanted, actually. Let me go back and see if I can edit. I can't edit this. Data, simulate. Sorry. Data, simulate. I did binomial. Yeah, so it's not good. But anyway, I just wanted you to see that's what they're doing. And then they go through and they find the mean of each one of these. Now, of course, since I made each one equal to 1, the mean of each 5 is going to be 1. But that's not always going to be true. So they're going to go by and get a mean of each one of these, and then they're going to get an average of the averages. And that's what they're doing on this next slide. And let's see. Okay, here the data of the following slide represents a sample mean for the 200 simple random size, okay, of n is equal to 5. For example, the first group is right there, and the mean of this first group is 2.44. And see, here's the whole group. Okay. And here's the second group. And then they go, the mean of the population is 2.46. The same as the mean of the population. The standard deviation of the sample mean is 0.0086, which is smaller than the standard deviation of the population. And they go through and show you the histogram, which all this is not testable. But what I do want you to see is that they went through and they simulated all these different numbers. And that's where this is what's behind chapter 8. Okay? Just you agree with me and everything will be okay. All right. I'll tell you when we get to the test stuff. Okay. Okay, you might want to write this down. As the size of the sample increases, the standard deviation of the distribution of the sample mean decreases. And that goes with the large number rule that I taught you back in Unit 1. The more people you actually survey, or the more people you actually include in your research, the better the accuracy, which means the standard deviation will not get smaller, it will get what? It's not going to get bigger, it's going to get smaller. And what does standard deviation mean? That means the spread. So if your spread gets smaller, that's a good thing. So as the sample size increases, as your research group increases, the standard deviation decreases. That's a good thing. So you might want to write that down because that could be a test question, at least on a standardized test. But it might be in your homework as a conclusion question. After you do the math, it'll say, well, what does this mean? And then this may be one of your choices. I'm going to skip through this. There we go. So I want you to write this down. You don't have to write down every word. The mean and standard deviation of a sampling distribution. The mean and standard deviation of a simulation. Okay? The simulation of all those numbers. Suppose that a simple random sample size is drawn. There's that n when I said n is equal to 5. Okay, is drawn from a large population with a mean and standard deviation. The sampling distribution of X bar will have this effect. So the mean of the sample distribution will be equal to the mean that's given. That's important. So you need to highlight that little part right there that says the sample mean will be equal to the given mean in the question. And the new standard deviation, the standard deviation of the mean will be that right there. So that's a very important paragraph. The standard deviation of the sampling distribution of X bar is called the standard error of the mean, and write that down. Okay? Here's an example right here. The weight of pennies minted after 1982 are approximately normally distributed with a mean of 2.46 and a standard deviation of 0.02. What is the probability that in a simple random sample of 10 pennies, we obtain a sample mean of at least 2.465? Now write this down because this is a test question. This is how it will be worded. So I've got I'm going to write this on my paper so I can show it to you. Mean, that's equal to 2.46, and a standard deviation, that's equal to 0.02. And they say, what if you basically get a random sample of 10 pennies? They want to know what is the probability of at least. At least means that the lowest number has to be what? 2.465. So that means greater than or equal to 2.465. Give y'all another 30 seconds to write that down. Maybe y'all can get on Facebook and ask the people on Facebook, what is the simple random sample? Maybe that's what y'all can do. How do you cook an egg? How do you boil water? Oh, my favorite is, does anybody know anybody that sells blank, blank, blank? You know, all you have to do is Google blank, blank, blank near me. Maybe somebody can tell me the psychology behind asking stupid questions on Facebook.
They just want attention, maybe.
I really do think that's it. I really do think that's it. I love the ones that get on there and say, oh, I'm depressed. That's the ones that get me. I'm just going to quit. I usually get on there and say, good, that's the easy way to do it. No, I don't. I don't mess with people like that because they're just hanging out a sign that says, I need attention. Okay, I'll shut up. Nobody's going to say anything. It's always good to have a conversation with your class. Thank y'all. I bet when y'all go on a date, y'all say, I'm not that hungry, don't you? I bet y'all do. I bet each one of y'all say that. Except for Mr. Dungan, of course. He's a guy and he's going to eat. But I bet the rest of y'all, when y'all go on a date, and Mr. Passetti, the rest of y'all, I bet y'all go, oh, I'm not hungry. I'll just drink water. And nothing. Y'all a hard case. Y'all know that? Is it me, or is it just the subject, or is it the, what is it? Why do y'all want to do this to me?
More force of habit than anything.
Force of habit. What, just not talking?
In classes, yeah.
Early.
Well, usually when the teacher asks you to talk, you should talk, you know? It used to not be this way. I really think it has to do with the phones and the way that students communicate with each other. They'll sit beside each other and carry on a conversation on the phone and won't even speak to each other. That's why these big companies put these people that don't talk, they put them in little closet offices down the hall. And nothing. Okay. So if I take this, and that's what they're doing right here, let me go back and pull up my handy dandy. So here is my drawing. And my standard deviation, my mean is 2.46. And that's going to be $2.46 plus 2 cents is 2.48. Plus 2 cents is 2.50. Plus 2 cents is 2.52. Minus 2 cents is 2.44. Minus 2 cents is 2.42. Minus 2 cents is 2.40. Okay, so that's chapter 7 stuff. Okay, that's that right there. And then they said, if you pick 10 more people or 10 groups or whatever, what is the probability that in that 10 groups, you're going to have a score of 2.465? Now, if this was not here, this would be a chapter 7 problem. So let's do chapter 7. Let's do it in blue. So I'm going to put an X through this in blue, and we're going to do chapter 7. So chapter 7. Okay, 2.465, 2.465. Well, between here and here, halfway between is 2.45. Okay, and we know that 2.46 is right here, and that would be 2.47. So 2.465 is almost 2.47. So it'd be right next to it. Now, if you had an older calculator, you would have to change this to a z-score. So that would be 2.465 minus 2.46 over 0.02. I'm going to take my handy dandy calculator out because y'all don't communicate with me, so I quit asking a long time ago. Closet office. So I'm going to take my handy dandy calculator out. I've asked Tri-County to buy this for me because last 3 semesters, I've been using the trial version, and I think Texas Instruments is getting mad at me. So I'm going to hit 2.465. Second quit. Clear. 2.465 minus 2.46. And divided by 0.02. 0.25. So I get a z-score of 0.25. So if you have an older calculator, you would type in normal CDF, so second vars normal CDF 0.25 to 9999. So let's do that. Second vars normal CDF. And of course, if you've got a new calculator, you would type in 2.46, 2.46 for the mean and 0.02 for the standard deviation. And then your lower is 0.10, that would be 2.465 and then 9999. Okay, that would be your newer calculator. But since we found that'd be 0.25 and 9999 and paste. 0.40. So by chapter 7, this area is 0.4013. And that's your answer for chapter 7. Okay, so in blue is chapter 7. But I'm going to bring back this n is equal to 10. And I'm going to recalculate a new z-score. And that new z-score is going to be 2.465 minus 2.46 divided by not 0.02, but 0.02 over the square root of 10. And that's what you got to remember to do in chapter 8. So I'm going to take my handy dandy calculator, make it a little bit smaller so y'all can see what I'm doing there. There we go. So clear 2.465 minus 2.46 divided by parentheses 0.02 divided by, and you can put the square root. I don't use the square root that often, but I'm going to use it here since we're plugging into a formula. I usually raise it to the 1/2 power. Oops, sorry. Let me delete that. Delete. There. Make sure you put the parentheses outside. Oh, shoot. I hit the wrong button. TM. Delete. Oh, my Lord. That's why I don't use the square root. So I'm not using it. 10 raised to the 0.5 power and close parentheses. Okay, so I'm going to take my answer, which is 0.005, and I'm going to divide by 0.02 over 10 raised to the 1/2 power, or square root of 10. And now my new z-score is 0.79. Okay, so now my new z-score is 0.79. Well, this is a half. 0.79 would be right in here. 0.79. Now remember, I'm finding the z-score because I've got an older calculator. And this is what you would do in an older calculator to find the z-score. 79056.
The calculator is blocking the paper.
Sorry. I can't show everything. I'm sorry. There you go. So now we're going to find this area right here. Now I can tell you this: your orange area will always be smaller than your chapter 7 area because you're dividing by this number, which is right here. Okay, so your area that you're always finding will be smaller than if you did the problem in chapter 7. So let's find our area. Take my handy dandy calculator. And I'm going to do second vars, normal CDF. Now I've already got everything in there except for the 99. I mean, I just got to put in 0.79. 0.79 and paste. .2148. 0.2148. So our orange area is basically 21.5%, or 0.215 or 0.2148. So if I chose 10 more people or 10 more pennies or 10 more whatevers, what is the probability that my weight is going to be above 2.465 grams or whatever? Basically, that probability is 21.5% or 0.215%. Where in chapter 7, it was just, what is the probability with this information here? What is the probability of 2.465? That would be 40%. And that's what you're doing in chapter 8.1. So let's see. Now, if you're using a newer calculator, you would just type in second vars, normal CDF. My lower is 2.465. And 9999 and 2.46. And instead of a standard deviation of 0.02, you would do, I wonder if it would do this, parentheses, 0.02 divided by the square root of 10. I've never tried to do this before. It might do that. Let's see if it'll do it. Yep. Now ours is a little bit off, but that's because of rounding. 2.2148. And this is 0.2146. And they make adjustments for that in the answers, in the solutions. Okay. So let's see what they got with the handy dandy. It's a miracle. Now I'm going to put this up so you can take a picture of it or write everything down, which you should have already got it down because I just did it for you. But in case you want to use that as an insert for your notes, there you go. Okay, so next slide. And I'm not going to go over this. Let's see, we're repeating sample mean for each 200 samples repeat. No. We've already talked about that. Write that down. The shape of the distribution of the sample mean becomes approximately normal as the sample size, increases. Okay, that's very important that you understand, because I told you in Unit 1, just like a few slides back, the large number rule. If you're going to do research, and I don't know how many of you will do research in the future. Some of you may go all the way to your doctorate and have to do a thesis. Thesis and a dissertation, you have to do research. Well, you're going to have 2 classes on research right before you do that dissertation. And you'll be revisiting this. The more you research, the better off you are. The more you survey, the better off you are. The more you count, the better off you are. So if you're a lazy person, that's going to go against your code to do more, all right? The shape of the normal distribution, it takes more effect as the sample size increases. Suppose that the mean time for an oil change is 10-minute oil change, 11.4 minutes with standard deviation. So you draw a picture right there. Oops, sorry. If you pick 35 more people or oil changes, okay, they're just showing you that the standard deviation, the new is, instead of 11.4, 3.2, it's going to be 11.4.54. That's the same thing we talked about. Square root of n is equal to 35. They're just bringing back that formula. They're just hammering that formula. Now, you find that z-score. Now, if you've got the newer calculator, you would just type in all the numbers in the problem, and you would want to get from negative 9999 to 11. You'd be on the left-hand side. But the standard deviation would not be what it was in the previous slide. The standard deviation would not be 3.2. The standard deviation would be 0.5409 with your newer calculator, because that is the new standard deviation. Remember, and I'm going to give you this. In Chapter 8, the difference in Chapter 8. Chapter 8 will give you an N and a probability. Okay, Chapter 8 will give you an N and a new probability. And in Chapter 8, you've got to remember the new standard deviation is the square root, N over this, standard deviation over the square root of N. So in this problem that we're just looking at on the PowerPoint slide, they say here's the problem they're giving us. They say a mean of 11.4 and a standard deviation of 3.2. Then they tell us that n is equal to 35. You research 35 more people or customers or whatever, and they want to know what is the probability that the oil change or whatever is less than 11. So the probability of X being less than 11. So here is the information that is given. Now, of course, you would draw a picture. We'll draw it on the next page. So mu is equal to 11.4. Standard deviation is 3.2. N is equal to 35. And P, X is less than 11. And I'm going to take my handy dandy red marker, pink, and I'm going to highlight that right there. And that's the difference between chapter 7 and chapter 8. So again, I'm going to do chapter 7 right here. $11.4, and that'd be what, 14.6 and 17.8 and 21. Help me out there. And oh gosh, 8.2, 5.0, 2.8, or 1.8. I hope that's right. All right, and then X is less than 11. So 11 is right here. And they want to know this. Well, if you got a new calculator, you would do from negative 9999 to, this is 11, and put in a standard deviation of 11.4 and a mean of 11.4 and a standard deviation of 3.2. Bada bing, you get an answer. So we'll do that. Second, bars. And we're going, since we did the old calculator with this other example, we're going to do a new calculator and just type in negative 9999 to 11, and mu is equal to 11.4, and standard deviation of 3.2. And then paste, and it's going to be less than 50%. 0.4503. 0.4503. Okay, so we just did chapter 7. So we'll just put that in a cloud. Now we're going to do chapter 8. We're going to do it in green. $11.4, 14.6, 17.8, 21, 8.2, 5.0, 1.8. Now, you don't have to do the z-score if you got a new calculator. If you got a new calculator, you just have to put 11 right about here. And then type that in, but you can't use the standard deviation. It's not going to be 3.2. The green standard deviation is called X bar. It's going to be 3.2 divided by the square root of 35. And that's the catch if you're using a newer calculator. If you're using an old calculator, you got to find this z-score. And that's going to be 11.4 minus 11 over this right here goes in the right there. So that'd be 3.2 over the square root of 35. Okay? And of course, it's going to shrink because this probability is always going to be less than the original if you did it in chapter 7. So it's going to be 30% or 20% or something like that. So let's take our handy dandy calculator and do it. Man, we got to finish. Second bars, normal CDF, and I'm going to do negative 9999 to 11, 11.4, and instead of 3.2, I'm going to do 3.2 divided by the square root of 35. So 3.2 parentheses divided by the square root of 35. Point 2298. So our new 0.2298. And that's basically how you do 8.1. Okay, let me go call the roll right quick. I don't want anybody going into convulsions. Some of y'all done went back to sleep, so. Y'all settle down, please.